This is AKG C460 B, and the oscillator coil just fell off and all the wires were broken. That's the base of the coil. So the wire is extremely thin. That's the microscope picture of the coil inside. And I was trying to restore it by unwinding it and trying to at least reverse engineer it. So I did reverse engineer it, but in the process I broke this wire several times because it's kind of beyond my abilities to handle things. Here you see the scale of the miniature wire in comparison with a dinosaur skin and gigantic fingers. See, I drop it and I pick it again, trying to do it again. Several attempts, but I reverse engineer it. I kind of counted the approximate amount of turns, and that's how the tap looks. It's just wires twisted together. This is the coil itself inside of the this ferrite contraption. So it's clean now without any wire. And the big problem for me was to find the right wire for this project. And surprisingly, I found that the coil from the wall clock, just regular quartz wall clock, is very close. It's a little thicker than the original wire, but it's still very close. So I used it. You can see how small it is. And it's very hard to solder it, because if you crank up the temperature on the iron, it just melts the wire itself. So I came up with this little contraption using a very thin double stick tape to hold the wires and to hold the coil itself, and then I wounded it according to amount of turns that I reverse engineered, and that's how I secured the leads with a hot glue on top of it. And that's the abomination that came out of this, the whole experiment thingy. Ugly, but let's see if it works. On the schematics, this coil is marked a U62 as a transformer. Anyway, it has 1, 2, 3, 4 leads, and I marked them A, B, C, and D according to the schematic. And that's how I represented it when I was trying to reverse engineer it. So when I reverse engineered it, unwound the whole coil, and that's what I got. I got the DC resistance A to D 9.5 ohm, A to B 2.2, and C to D 1.5 ohm. So the winding instructions go like this. You start, it's D to C, it's 9 turns, then you have to make a tap, which you kind of twist the wires and it becomes a tap. Then C to B, it's the biggest part, is 160 turns. You make another tap, and the last one is B to A, is about 15 turns. So I did that, and then I just tried to mount it from the back of the PCB just to test it, and hooray! I see the oscillation is back on the scope. And I've got 60 volts DC at the output of the rectifier, which is according to the specs. So I didn't have to adjust the trimmer potentiometer and left it as is. So now after this, this is the picture how you can see the points where to wire it. A is the capacitor, C is the collector of the transistor, D is the output to the rectifier, and B is to resistor on the base. You can see it here. The base of the coil previous is not removed, but then I removed it, and the whole thing looks like this. I secured it with a little molten candle wax, and it tests very good, nice. If somebody did try to do something like this, please let me know. I'm really curious.